स्टार्ट हुआ नहीं है। हरीश, मिश्रा जी, सुशांत, आर्यन, लेक्चर स्टार्ट हुआ नहीं। स्टार्ट करो।
पूरा है शहर में यार, शहर से कट कैसे हो जा रहा है यार। चल रहा है। एक तो हाथ कर गया तू, कर गया। हाथ कर गया। ठीक है। गुड आफ्टरनून क्लास। गुड आफ्टरनून क्लास। तो आज हम लोग मैथ्स का अलजेब्रा का एक टॉपिक ट्रिग्नोमेट्री, उसका बेसिक्स हम आज पढ़ने वाले हैं। तो ट्रिग्नोमेट्री इज द स्टडी ऑफ रिलेशनशिप्स बिटवीन एंगल एंड द साइड्स ऑफ ए ट्रायंगल. Basically, we study the relationship between the sides of a triangle, giving them names and finding the values. And the basic difference between geometry and trigonometry is that geometry focuses on shapes and the properties, while trigonometry focuses on angles and the relationship to the sides lengths. So बेसिकली ज्योमेट्री में हम शेप्स, उनकी प्रॉपर्टीज, वॉल्यूम, पेरीमीटर पढ़ते हैं, वाइल इन ट्रिग्नोमेट्री हम उसका रिलेशनशिप विद साइड लेंथ्स, माने कि हम उनका साइड का लेंथ और वेरियस अदर प्रॉपर्टीज पढ़ते हैं, जो अब आज हम पढ़ने वाले हैं। तो जैसे आप इधर रीड कर सकते हो, ज्योमेट्री यूजेस कॉन्सेप्ट्स लाइक एरिया, पेरीमीटर एंड वॉल्यूम, whereas trigonometry uses concepts like sine, cosine and tangents, which are today we are going to learn. So also trigonometry is used in various fields like engineering, physics and astronomy, which are very renowned fields.
बहुत अच्छा बता रहा, तो आराम से बता।
Yes sir. So
पहला वाला
as
स्लाइड
per
ना, पहला वाला स्लाइड बहुत भारी था। पहला स्लाइड कौन सा था तेरा? ये
geometry.
हाँ, ज्योमेट्री। बेटा ये पेन नोट इतने मोड़े इतना बच्चों लगे, ये पेन से लिख सकते क्या ना इसके ऊपर? अच्छा, ये पहला वाला स्लाइड पे तू क्या बताएगा?
Sir,
ज्योमेट्री बता, ट्रिग्नोमेट्री में ज्योमेट्री क्यों इंपॉर्टेंट है?
So basically,
पहला
when we
हाँ
study
वो बता ना।
trigonometry is based on the right angle triangles, and right angle triangle is a 2D shape which comes into geometry. And while studying the geometry, a topic comes that is coordinate geometry, in which a distance formula, which is a important and a basic formula, is based on
वॉल्यूम बढ़ाना
trigonometry.
चाहिए। ये मालूम है ना साइन किसका शॉर्ट फॉर्म है?
Yes, sir.
हाँ, और कोसाइन कोसाइन का शॉर्ट फॉर्म कॉस रहता,
Cos and
और
tangent
टेंजेंट
is
का
short
शॉर्ट
form
फॉर्म
tan.
टैन रहता।
Yes.
हाँ,
And
तो सीकेंट
going
का
on,
शॉर्ट फॉर्म सेक रहता, कोसिकेंट का शॉर्ट फॉर्म कोसेक रहता, को टेंजेंट का शॉर्ट फॉर्म कॉट रहता।
quadrant. Going on to our next slide, which is angles and triangles. Understanding their relationship next. The
नहीं उससे
concept.
ये बोला मिश्रा, ये बोलना चाहिए अपने कि वो एस्ट्रोनॉमी लिखा देख तूने पहले स्टार्ट में, बहुत भारी पॉइंट लिखा है। एस्ट्रोनॉमी पढ़ना है आजकल, स्पेस एक्सप्लोरेशन पढ़ना है, उसको अंडरलाइन करना देख, पहला स्लाइड पे था तेरा, एस्ट्रोनॉमी का ओलंपियाड्स भी
इधर राइट का ऑप्शन नहीं बता रहा।
देखना। अच्छा ठीक है, लेकिन एस्ट्रोनॉमी सब लोग पढ़ो बच्चे लोग, एस्ट्रोनॉमी जो है ना बहुत इंपॉर्टेंट है। मिला के सबको एस्ट्रोनॉमी? एस्ट्रोनॉमी सीखने के लिए भी फिजिक्स और इंग्लिश और मैथ्स आना चाहिए, ये भी इंपॉर्टेंट है। आया कि नहीं? एस्ट्रोनॉमी को अंडरलाइन कर। वेरी गुड स्लाइड। चलो नेक्स्ट आगे मिश्रा।
नेक्स्ट स्लाइड।
हाँ बोलो।
Angles and triangles, understanding their relationship now. So the first concept while studying angles and triangles comes is angles. The description of the angle is that measures of rotation between two lines is called as an angle. The units to measure angles are in degree, radian, and centesimal unit is that grade. So
ग्रेड
these
लिख,
are the
ग्रेड
three.
ग्रेड ग्रेड। हाँ, अभी एक
These are the
रिलेशन लिख,
three.
अमर अकबर एंथनी।
These are the three units in which we measure the angles, and these are the Amar Akbar Anthony's while we measure the angles. So degrees basically the whole number in which we measure the angle. Radian includes the constant pi while measuring the angle, and grade uses some 100 as in. So basically, uh, while studying trigonometry, the three major measurements of angle are grade.
नहीं ये सट्टा लिखना, सट्टा लिख, सट्टा D/90। हेलो,
हाँ सर।
D/90, D/90 लिख रहा क्या? ये देख, ये तो दिख रहा है क्षेत्र पे, ये होगा का सॉफ्टवेयर में 25 से हो बहुत कम है। सिर्फ ये पैरेलल बनने का जितना दुकान है ना सब इससे लेता है। इसका भी D/90 इज इक्वल टू
G/100.
D/100 इज इक्वल टू 2r/pi इज इक्वल टू 2r/pi।
So this is the basically relationship between degree, grade, and radian. And this is how we convert degree into grade, grade into radian, and radian into degree by using this formula, or also called as satta. This is our satta for changing the degree of changing the measure of our angle.
ठीक है, कंटिन्यू नेक्स्ट।
Now we will study key properties of sum of interior angles of triangles and types of triangle. So sum of interior angles of a triangle is 180 degrees. So 180 degree is equal to 200 grade that is equal to pi. So sum of interior angles of a triangle. Let the triangle be A, B, and C. So the interior of the triangles are this one, right here, and this one. So basically, the property states that the sum of interior angles, that are angle A, B, and C, is equals to 180 degrees. This is a this is the most fundamental property while we do sums of problem based on triangles. Moving on to our next property, that is types of triangles. So this is a very vast topic, and here are some types of triangles which are right angle triangle, that is yes. So our types of triangles are uh, right angle triangle, acute angle triangle, obtuse, equilateral, isosceles, and scalene. Uh, this is a brief topic. This is not a brief topic, but
राइट एंगल ट्रायंगल ड्रॉ कर राइट एंगल ट्रायंगल ड्रॉ कर बोलना ऑर्थो सेंटर किधर रहता राइट एंगल पे रहता
this is
हाँ
the
वहां पे
right
ऑर्थो
angle
सेंटर
right here. Right
एक्स लिखो
angle equals to 90 degree.
वही ऑर्थो सेंटर का पॉइंट भी रहता
This is the most key triangle while studying trigonometry. So this is the prime example of a triangle in which we use sine, cos, and tan. And this is the triangle through which we will study the trigonometric ratios. So remembering this triangle is the most important. This triangle has one angle which is equals to 90 degree. So it's this angles interior angle sums also becomes to be 180 degrees. But one angle is 90 degrees, so it becomes easy for us to find the rest other interior angles. And now we come to acute angle and obtuse angle triangle.
मैंने ये
These two
बोला राइट एंगल ट्रायंगल का ऑर्थो सेंटर है ना राइट एंगल ट्रायंगल का ऑर्थो सेंटर जो है वो वर्टेक्स ऑफ राइट एंगल पे रहता ऑर्थो सेंटर क्या रहता जहाँ पे एल्टीट्यूड इंटरसेक्ट करता
yes sir. तो राइट एंगल ट्राइंगल्स का एल्टीट्यूड उसके एल्टीट्यूड्स को जब एक ट्राइंगल के इंटरसेक्ट करते हैं तो वो ऑर्थो सेंटर पे मिलता है, ऑर्थो सेंटर हमें मिलता है। और राइट एंगल ट्राइंगल का ऑर्थो सेंटर राइट हियर, दिस साइड इज कॉल्ड एज हाइपोटेनस, दिस हाइपोटेनस, and when we make the altitude meet of a right angle triangle and we get a ortho center which is right on a hypotenuse.
हाइपोटेनस दे रहे बच्चा नाम दे ना एबीसी नाम दे एबीसी नाम दे ट्रायंगल को नाम दे हाँ वो सी को जो है ना सी को ऑर्थो सेंटर बोलते हैं सी को क्या बोलते हैं
Ortho center.
हाँ बोल लिखो तो ऑर्थो सेंटर लिख सी पे एल्टीट्यूड इंटरसेक्ट क्यूट एंगल ड्रॉ कर लेगा
Moving on to our next triangle which is acute angle triangle.
मतलब क्या होता है ऑर्थो ऑर्थो का मतलब ही राइट एंगल होता
Yes sir. Acute angle triangle is the triangle in which all the three interior angles are acute, which acute means that an angle is less than 90 degrees. So this is basically a simple acute angle triangle for our reference. These both of the three interior angles will be less than 90 and their sum will be greater than 180. That's why this is called as an acute angle triangle. An obtuse angle triangle is quite the
है
opposite.
एक्यूट एंगल ट्रायंगल पे ना मिश्रा एक्यूट
हाँ
एंगल ट्रायंगल की एल्टीट्यूड ज्वाइन करना, एडी बी और सी एफ ज्वाइन कर। ए से हाइट बना एडी, हाँ, बी से बना बी, हाँ, उसको जो तीनों जो मीट हुआ है ना, उसको एच बोलो। तीनों का जो मीट हुआ ना, एच बोलो।
सर, वहाँ पे लिखने नहीं हो रहा।
हाँ ठीक है। वो जो पॉइंट है
हाँ
ना, तो क्या बोलना, सट्टा सट्टा ये बोलो कि एक्यूट एंगल ट्रायंगल का ऑर्थो सेंटर ट्रायंगल के अंदर रहता।
okay. So when
क्या
we
बोल,
join the altitudes of an acute angle triangle, the resultant orthocenter resides in between in right the center of the triangle, uh, in and that's not the case for the obtuse angle triangle while we study it. Now we explain the obtuse angle triangle. So this is the most basic acute obtuse angle triangle, and
एक्यूट एंगल ट्रायंगल का जो एल्टीट्यूड है बाहर आता, एक्सटेंड
yes.
करना बाहर। हाँ, वो एच नाम दे, एच, बड़ा एच।
And
एच मतलब ऑर्थो सेंटर। तो तीन सट्टा बोल, अमर अकबर एंथनी। राइट एंगल का किधर है, राइट एंगल का मिश्रा जी।
तो हाँ सर, चल नहीं रहा है सर
राइट
बरोबर।
एंगल का,
सर टैब चल रही है ना।
हाँ
टैब खराब है सर।
हाँ ठीक है, राइट
पेन
एंगल
पेन
का
भी
वर्टेक्स
खराब
पे रहता।
है। मैकबुक ला
बोलना।
मैकबुक।
And so we studies these three triangles, which are right angle triangle, acute angle triangle, and obtuse angle triangle, and their altitudes. So when we join the altitudes of an acute angle triangle, the orthocenter resided in the center of the triangle, and quite the opposite in the obtuse angle triangle. When we joined these altitudes, the orthocenter was outside the triangle, and in the case of hello,
राइट एंगल ट्रायंगल,
and in the case of right angle triangle, the orthocenter
ऑर्थो सेंटर इज एट द वर्टेक्स ऑफ द राइट एंगल।
orthocenter resides on the vertex of the right angle triangle. This is the Satta.
वेरी गुड,
Uh,
कंटिन्यू नाउ।
this is Akbar, Amar, and Anthony. And moving on to our next slide, trigonometric ratios. So this is the most important topic of the day, and the whole lecture is based on this slide, and I will have to thoroughly explain this slide. So these are the trigonometric ratios: sine, cosine, tan. Short form for sine is sine. Short form for cosine is cos, and short form for tan is tangent is tan. So basically, to explain this, I will have to create a right angle triangle, naming it A, B, and C, and the right angle be uh, at angle B. So this becomes a hypotenuse. This becomes if we make the theta be here at C, so this becomes our opposite, and this becomes the base. So this will be our triangle for the reference of the to study the trigonometric ratios. Sine. Sin theta. For theta, sin theta here, opposite side upon hypotenuse. So opposite side becomes AB, and our hypotenuse becomes AC. So for the ratio sin theta, the sin theta ratio becomes AB upon AC. If we try to give the length of the sides of the triangle, hypotenuse, according to the Pythagorean triplet, the hypotenuse should be pi, base should be 3, and the opposite side should be 4. This way, our sin theta becomes 4 by 5. So, moving on to the next trigonometric ratio, cosine, that is cos. Cos theta. Uh, I forgot to mention that we are assuming theta as a reference angle. So by referring theta with our reference angle, we get these ratios. So our cos theta will be adjacent upon hypotenuse. The adjacent side is the base side of the theta. So base is 3 and the hypotenuse is pi. So this becomes our cos theta. And tan theta, tan theta is uh, opposite upon adjacent. So for our reference angle theta, tan theta becomes 4 by 3. And uh, these are the fundamental trigonometric ratios. There are other three fundamental trigonometric ratios which are quite simple to learn. And the other trigonometric ratios are cosec, sec, and cot. By these six trigonometric ratios, we can solve the trigonometric sums and ratios. And there is a major note that these ratios are defined for right angle triangles only. We cannot use an obtuse angle triangle, an acute angle triangle, or any other type of triangle for the reference of trigonometry. Only trigonometry is based on right angle triangle, so ratios come after the 90-degree at angle. Uh, this is uh, this here is a mnemonic to learn for to remember the sides ratio. For for sine, the ratio is opposite upon hypotenuse. So, and for cos it is adjacent upon hypotenuse, and for tan it is opposite upon adjacent. So it becomes really easy to remember them by learning this mnemonic SOHCAHTOA, and this can also be called as satta. Now we will learn the application of trigonometry in real world. Uh, most of you have the doubt why do we have to learn trigonometry. So these are the real world based applications of trigonometry. Trigonometry is used for surveying, measuring distances and elevation using angles. There is a whole different branch of trigonometry which is called as height and distances, and the whole that whole branch is based on measuring the distance and elevations using angles and using our trigonometric ratios. So this is the most these are the most the applicable real world based applications of trigonometry. Next comes navigation. Navigation is used in determining location and
गुड गुड गुड, चलो
direction.
कंटिन्यू. नेक्स्ट वाला स्लाइड बता, नेक्स्ट वाला.
सर कंप्लीट होने देना.
हाँ, ये कंप्लीट होने के बाद
Determining location and direction using trigonometry. So navigation is quite simple. That there is a
आमदार कौन है? आमदार आमदार जग्गू कौन है?
profession
जग्गू
called as merchant
मोटे कौन
navy.
है?
Merchant
ये
navy
सट्टा
in
के
which
नाम से कौन है? सट्टा के नाम से
there is a profession called as merchant navy in which
स्वप्निल. स्वप्निल देख रहा जरा, जो जो अलग अलग नाम से है कौन है, जरा चेक कर.
the profession merchant navy as and sailing is solely based on navigation, and for navigation trigonometry is a wild concept used in that profession for determining location and direction. Similarly in physics, trigonometry is used to find distances between two planets using plane angle and solid angle. Those two concepts are way too forward concepts, and we will learn them eventually. And in engineering, designing structures, bridges, and other complex objects require fundamental knowledge of trigonometry, and they help in making these structures and bridges. Uh, so engineering is also is a field which uses applications of trigonometry. And architecture, calculating angles and dimensions for a building's design, is a field using trigonometry, because
Thank you. Thank you.
architecture, this is the table: surveying, navigation, engineering, physics, and architecture. And these are their major uses of trigonometry in those fields and professions. So, some of you might be aspiring for these fields may have may have to learn trigonometry well enough. And in the next slide here, we are going to learn the trigonometry as a concept. So, starting to explain this slide, trigonometry a powerful tool. The heading of the slide only explains us what a powerful tool is trigonometry really is. Just imagine that a plane flying above the sky, and using trigonometry, you can find the distance of plane from the ground itself. What an what an amazing concept is that! So there are three major concepts in trigonometry: unified concept, wide applicability, and future exploration. Unified concept includes angles, triangles, ratios seamlessly intertwined. So, uh, some uh, some of you might like to create a mind map while learning any subject. You can divide trigonometry into three major parts, which is angle, triangles, and ratios. And seamlessly, wherever or however we studied trigonometry, these three will always be used. And wide applicability, from engineering to and architect to physics and astronomy. trigonometry is used because it is a major algebraic uh, algebraic uh, lesson and chapter which we have to learn at a very tender age or young age. And as we move on to a different standard or higher standard, the subject appears to be get a bit harder and harder. Thus explains us to why trigonometry is a very important subject. And before concluding this topic, I would like to explain the key takeaways we learned in this session. Trigonometric ratios, which are sine, cosine, and tangent. These are the ratios which we learned in this lecture, and I thoroughly explained you the ratio, the mnemonic, and their properties. Trigonometric ratios are the foundation for solving problems. As we move forward in future lectures, we might see that trigonometry ratios are the fundamental in for solving the sums and problems of trigonometry. And these are not a topic which you might to neglect, as these are the major solving triangles, determining known unknown sides and angles. So uh, Triangle triangle itself, a 2D shape, is a vast subject while studying maths, as there are many types of triangle which are scale triangle, isosceles triangle, right angle triangle, acute obtuse triangle, and uh, many other triangles and their properties. And the application for this both is in real world are very vast, as explained in the previous slide. So this was my PPT, and this was my lecture, which I hope you liked. And uh, before concluding, I would like to say that my name is Siddharth Harish Mishra, and I conducted this lecture on the topic basis of the basics of trigonometry. And I hope you got explained well enough the basics of trigonometry and the triangles and trigonometric ratios. And thank you for the lecture.